All right, today we're covering 6-3 Part 2. So we did division of polynomials using long division last time. This time we're going to use something called synthetic division. So there's just a set of steps or a procedure that you go through to use synthetic division. Someone has figured out that this works, and I will guide you through the process, and we will practice a few problems. All right, so synthetic division is a shorthand method of dividing a polynomial by a linear binomial. So if we remember, this means you can only use it if you have a binomial which is two terms and it's linear, which means that the degree is going to be 1. So there's only certain cases when you can use this, but when you can use it, it's a nice shortcut. So we use the coefficients. So, and as it says here, by using only the coefficients of the polynomials. So for synthetic division to work, the polynomial must be written in standard form using a 0 and coefficient for any missing terms. So again, you're going to fill in missing terms, else it won't work out correctly. And then the divisor must be in this form. So x minus a. So that means if you have something like x plus 2, since we have a plus 2 here, a is going to be a negative 2. And I say that because you're going to have to identify a to do your synthetic division. All right, so that's kind of the definition. Here, the synthetic division method is just the steps that you're going to use to perform a synthetic division. So here's the problem. Divide 2x squared plus 7x plus 9 by x plus 2 using synthetic division. So step 1, we want to write the coefficients of the dividend. So dividend, again, the dividend is going to be this part. And we're just writing the coefficients of the dividend. So in this case, it's 2, 7, and 9. And then in the upper left-hand corner, so I actually end up writing it just like it was a long division. I would do 2, 7, 9. We're going to write a. So we're going to find a and write it up here in this corner. And in this case, just like the example I showed you, x minus a, if we have a plus 2, that means a has to be a negative 2. So that's where this comes from. So once you have that done, it says copy the first coefficient in the dividend below the horizontal bar. So you're going to make a horizontal bar. They didn't tell you to do that. And then we're just going to bring down the first coefficient, which is the 2. All right. After you have that, step 2, multiply the first coefficient by the divisor. So what does that mean? We're going to multiply this coefficient that we brought down by this negative 2, which is our a. That gives us negative 4. And then, and this is the part that gets confusing because in long division we subtract one row from the other. We're going to add here. So just be careful. That's one of the problems I see with synthetic and long division. People get confused. So 7 and a negative 4, the answer of that is going to be, is going to be 3. So that we get that by just subtracting 4 from 7. All right, now we're going to repeat step 2. So we're going to multiply our negative 2 and the 3 that we got from the last step to get negative 6. We add those two together. We add 9 and negative 6 to get positive 3. And it says draw a box around the last sum. So you can see we don't have any more columns, so we're done. And so what does that tell us about the answer? Well, the answer is written using this. So we have 2 different numbers. So this is going to be our constant. This is going to be our x to the first power, and if we had another number, that would be the coefficient of the x squared. But in this case, we only have a constant, and then this goes in front of 2x. This goes in front, the 2 goes in front of x. The 3 is our remainder, so it's going to be written as 3x plus 2. and that's done. Then you're done. So this last number here is your remainder, and that would be the answer to that division problem. That's the procedure, so we're going to go through a few examples. All right, divide using synthetic division. So first we're going to write the coefficients. So we have a 3, a 9, and a negative 2. And then we want, remember, we're identifying A. So A is equal to, in this case, 1/3, because remember, it's x minus A. Since we have a minus 1/3, that means A is going to be a positive 1/3. All right. So this is what we have. Then we're going to pull the A down. Pull the 3 down here. We're going to multiply 1/3 times 3 to get 1, and then add the 2 together, and that gives us 10. Now we're going to do it again. We're going to multiply 1/3 times 10 to get 3 1/3. A negative 2 and positive 3 1/3 is 1 1/3. And then how are we going to write this? We kind of go from right to left. Our 10 is our constant. Our 3 goes in front of our next term, which would be x to the first power, so it's 3x plus 10, and this is our remainder. So 1 1/3, which is going to be just 4/3 over x minus 1/3. And that's your answer. So if you can remember the procedure, it makes division of polynomials fairly simple. But remember, it has to be by a linear binomial. All right, let's try another one. Divide using synthetic division. So notice in this time, we're missing some terms, so we have to be careful here. Again, x minus A, so since this is a plus 2, our A is actually going to be equal to negative 2. So we have a 3, a negative 1. We're missing our squared term, so we need to put a 0 for that, else we would not be in the right order. And then we have 5x and minus 1. So we have to fill in for the missing coefficient of x squared. And now we're going to use our process. Bring the 3 down. Whoops, this is the next step here. We're going to bring our 3 down, multiply that by negative 2 to get negative 6. Negative 1 and negative 6 gives us negative 7. Multiply negative 2 and negative 7 to get positive 14. 0 and 14 is positive 14. Negative 2 times 14 is negative 28. And then 5 minus 28 is negative 23. Negative 2 and times negative 23 is positive 46. And then negative 1 and 46 is positive 45. So those are our coefficients. So how are we going to write the answer? Well, again, you're kind of starting from going right to left. So 23 is our constant. It's actually a negative 23. And then 14 is our x to the first power. Negative 7 is going to be our x squared. And then 3 is going to be our x cubed. Oops. So this is hard to see. This should be a negative 7x squared. And then lastly, plus our remainder 45 over our divisor, which is x plus 2. And whoops. And you can see that's the answer that they have here. So the one point of confusion is, what do I do once I get to this step here? You take those numbers and you're working from right to left to use these as your coefficients. All right, I want you to do this one. We will do this one in class. So that's synthetic division. We can actually use synthetic division for another purpose. We can use synthetic division to evaluate polynomials. So what does that mean? If we have p of x equals x cubed minus 4x squared plus 2x plus 1, and let's say I wanted you to find p at 5. That means plug 5 in for x and give me the value. We can use synthetic division to do that as well without having to plug it in and do the calculations. you can use something called the remainder theorem, and it's called synthetic substitution. So when you use synthetic division to evaluate polynomials, it's synthetic substitution. So remainder theorem says if the polynomial function p of x is divided by x minus a, then r, the remainder r, is p of a. So it means if we went through the synthetic division, if we took this polynomial and divide it, use synthetic division to divide it by x minus 3. So a is 3, here's our coefficients, we go through our synthetic division, and you can see our remainder is 7. What does that mean? It means the value of the polynomial at 3, which is our a here, is equal to 7. So if I plugged 3 into this polynomial here and calculated it out, I would get 7. So it's kind of a nice little, well, it's very clever for one thing, but if you had a very complicated polynomial, it might actually be easier. All right, so we're going to try this. Use synthetic substitution to evaluate the polynomial for the given value. So first of all, for x equal 2, so we don't even have to figure out what a is. They're telling us 2 is here. And then we're going to put in our coefficients of our polynomial, 2, 5, -1, and 7. So again, we don't have to find a. They essentially give it to you. And now we're going to do our synthetic division. We're going to pull down our 2, multiply 2 times 2 to get 4, add 5 and 4 to get 9, multiply 2 times 9 to get 18, add 18 and -1 to get 17, multiply 17 by 2 to get 34, and then 7 plus 34 is 41. So p at 2 for that polynomial is going to be 41. And you can check it. Plug 2 into this polynomial and see if you get 41. And you should if you've done everything correctly. All right, so you are going to try one in class, this one, and we will go over it in class as well. That wraps up polynomial division. Here's the homework. And make sure you ask any questions during the lesson so that you can get through the homework properly.